All right, good morning. This is Tim Stewart. I am president at Visual Decisions, and we're here today to talk about minimizing mean time to repair with Industry 4.0. At Visual Decisions, we've been in the business of utilizing information from the shop floor to improve operations since about 2002. We help our customers combine the smart factory with the lean factory to drive improvements to cost, throughput, and quality. Our customers have seen dramatic improvements, such as 30% increases in OEE, 50% scrap reductions, and much more. Just like wearing a Fitbit won't automatically make you thin, implementing technology for Industry 4.0 won't automatically make the business better. The culture of the organization and the business processes must be adapted to take advantage of the new capabilities to drive real improvements. That's why we have a unique approach to work with our customers to adapt processes to take advantage of the new capabilities and help establish a true data-driven manufacturing culture. Today, I'll be talking about different ways to minimize the mean time to repair. Mean time to repair is a simple concept. Just take the average length of time the machine is down before it is repaired, and that average is the mean time to repair. It's a critical component of optimizing the overall uptime of the equipment. An MTTR of 0 would mean that the equipment is instantly available again after failure. So we definitely want to minimize it. As I go through the presentation, just one quick note: if you have questions, please enter them into the Q&A, and I will answer them at the end of the presentation. I'll also have this presentation available on the website, visualdecisions.com, and you'll be able to both listen to the recording as well as download the presentation itself. All right. So how do companies today get equipment back up and running again? And from maintenance practices perspective here, we're not talking about autonomous maintenance or preventive maintenance or condition-based or predictive or any of those other wonderful practices. This is pure reactive maintenance that we're going to discuss here. And you can start by breaking this down into a few different components. If you look at the total time to repair, you can look at that as the initial time to response, the time during that first repair effort, and then subsequent time if the repair isn't made on that first try. So think of it like this: your car's engine light comes on and you call the shop to make an appointment. The time until you can get your car into the shop is the initial response time. At the shop, they try to fix the car, but find that they need a part that they don't have in stock. So that first trial is that second part of the time during the first repair effort. And then the time you spend waiting for that part and subsequently fixing your car afterwards is the penalty that you pay for not getting it right on the first try. So that's kind of how we'll break this down. And next week, we're going to focus on the subsequent time to repair and how we get that first time fix rate as high as possible. Today, we're going to focus on the time to the initial response and the time during that first repair effort. So if we break this down into a timeline, we can look at the components in even more detail here. So let's say that we have a packaging line or a bottling line, and a failure occurs on the line, and so production stops on, let's say, the filler. And let's say that the operator is down refilling the cartons, and so doesn't notice right away that the filler is down. So there's some amount of time before the operator is aware that the filler has stopped. And once the operator is aware, then he needs to get over to the filler, see why it stopped, whether it was just a jam that he can clear himself or herself, or whether they're going to need help. And let's say that they've decided that they need help now. So now the operator has to take some step to make maintenance and engineering or whoever they need assistance from that there's a problem. And this can take a lot of different forms in different companies and different workflows. It may be that they pick up a phone, in which case they have to go to a phone. Maybe that they have, radio where they can let somebody know. Maybe that they have to walk over to a computer, pull up an application, and create a work request. There's a number of different ways that they can do this, but at some point they have to give some signal to maintenance and any other support teams that are required that they need the assistance. Then maintenance basically needs to process that. They need to assign somebody to the problem, which itself can be problematic because in a lot of maintenance departments, you have people that specialize in electrical versus people that specialize in mechanical. And they're kind of taking a guess based on what they know about the problem from the initial description and what they know of the line and so forth as to which is typically more frequently required for somebody to go out there. And so now you have somebody assigned. Well, that person themselves may be already busy doing things. And so they may already be on a task or on a job, out at a different machine and so forth. And so now you need to wait until that worker is available. And then they have to travel to the machine, usually bringing a maintenance card or something along with them so that they have tools and so forth that they may need when they get there. So now we've kind of finally gotten to the point where maintenance arrives at the machine. And now they can begin the process that we typically think of as fixing the machine. So first they have to diagnose the issue. So, what happened to the filler to cause it to stop? And, that itself can be, somewhat of a lengthy process, depending on the failure, depending on the experience of the person, how unique the problem is, and so forth. And then they have to actually fix the issue. And, hopefully that's it and the problem is fixed, but, they may not have the right tools. They may not have the right parts that they require, or they may not have the right knowledge to fix the problem on that first try. In which case, you either have to bring additional assistance out to the machine, or you have to have that person go back, get the right tools, get the right parts, et cetera, order those parts and so forth, and try again later. And so we're going to be focusing on these first steps, through the response and then the initial repair effort. And then next week, we'll talk about if we have to try again later and how to avoid that. All right, so that's a lot of steps, and it can take a while before the machines get back online when maintenance is required. So how do we help with this? How do we get the machine back up and running quicker? Well, all of these activities can benefit from Industry 4.0 solutions, augmenting the traditional approach. And things such as I-IoT or machine learning and augmented reality and others can notify people, automate workflows, help classify and detect the issues, and help ensure that the activities are done correctly and more. So let's take a look at some of these solutions next. So if we look at I-IoT, and we think about what it is in case you're not familiar, basically it describes a network of physical objects, things that are embedded with sensors or software from PLCs, et cetera, to connect and exchange data with other devices and systems over either the internet or your local area network and so forth. And typical things that are included within an I-IoT system are data collection, data routing, persistence of the data, event processing, communication, so notifying people of alerts, et cetera, user interfaces, machine learning systems can be embedded within there and so forth. And they typically ship with just some out-of-the-box functionality, but the idea is that they can provide basically a complete toolkit to build any application within that sphere of, the Internet of Things, which is an entirely fuzzy term that encompasses just about anything if you ask the right person. Augmented reality applications can utilize your phone, can utilize a tablet, you can have the glasses that overlay images on top of the background and so forth, and really provide a brand new mechanism on the shop floor to do things that we just haven't been able to do before. And so, in the past, you either had work instructions like in a book, or you had work instructions on a computer screen, but you couldn't both look at the process itself, and those work instructions at the same time. And AR not only gives you that ability to kind of overlay the work instructions directly on the equipment and so forth, but it also gives you the ability to basically do like a FaceTime session, but with annotations and instructions and everything else, where you can get that remote assistance directly in the process itself. And then artificial intelligence or machine learning gives you the ability to have the computer do diagnosis, classification, detection, all kinds of different tasks that normally require human intelligence or have in the past, and can automate a lot of these different processes for diagnosing what's happening on the equipment. All right, so how do we go about minimizing mean time to repair with some of these different solutions? So if we start off by looking at machine monitoring and some of the visual factory pieces that we could put in place, when we utilize an I-IoT system, we can have the operator be made immediately aware that the machine has stopped and that there's a problem. So in our example that we're working with here, where the filler stopped, but the operator's down, by the packaging equipment, even though he's not physically present at the filler, he can be made aware pretty much instantly that there is a problem. And so whether it's andon lights or whether it's an alert that goes to a phone or pager or whatever, or different visual displays across the line, the operator can be made immediately aware that there's a problem. And so very, very easily we can eliminate or minimize at least one portion of this problem. And so if we look at asset monitoring within these different solutions, you can take that information directly from the machine. You can look at the different portions of the line and so forth, and make people aware of everything that's going on within that equipment. So then if we take the next step and we look at analytics within that process. So now we not only know that the filler has stopped, but by monitoring the details of what's going on within that filler, we can actually understand some of why it stopped. And by understanding why it stopped and being able to utilize intelligence to basically automatically diagnose what the problem is, we can tie that into some sort of system, whether it's a process FMEA or whether it's some other mechanism to help the operator decide immediately, right when they're notified that there is a problem, of whether they're going to need help or not. Is this something, is it just a jam? If it's just a jam, then the operator can go over there and clear the jam and have things proceed again. Is it just a reset or something like that that needs to happen? Great, the operator can do it. But if it's something that's outside of those normal failure modes and something that we can identify that the operator is going to need help with, then we can basically automate some of these steps where instead of having the operator walk over there, do some initial triage on what's going on, we can eliminate the need for that time and basically say that, okay, we know the operator is going to need the assistance, But furthermore, if we look further out in time to when the repairman gets there, the maintenance person gets there and is going to diagnose the issue, we can minimize that time as well based on some of the information that we're collecting. So if we know the failure mode, we know exactly what happens, we can provide that information to the maintenance person as well when they get to the machine, and minimize the time for that process as well. So we can address basically, 3 different parts of that by doing these things. And this really comes down into, doing that real-time production performance monitoring, tying that into the machine learning side of things, and being able to not only sense that there is a failure, but take the fault codes from the machine, take the process variables and so forth that are coming from the PLC itself, and temperatures or vibrations or anything else that might be relevant, and now utilize that information to diagnose what actually happened. And so in many cases, maybe not all of them, but in many cases, we're going to be able to significantly reduce the amount of time that those steps would take. So the next step now is taking what we've done before, but adding integration into this. And one of the great things about these I-IoT systems is that they are built to integrate with just about everything. And so they can act as a hub on the shop floor for coordinating different activities. And so if we think about what needs to happen here, where not only does the operator need to know what's going on, but now we need to make maintenance and any other support staff aware of what the problem is. We've done some level of diagnosis so we can pass information along. We can make some initial determination of, do we just need to notify maintenance, or do we need engineering support for this type of issue? We can automatically create the work tickets within the maintenance system and so forth. We can automatically, see who gets assigned and so forth, and determine the right type of worker that is going to be required for this type of problem. And so a lot of this can be automated, where we not only are notifying the worker and addressing those issues at the line, but now we're coordinating across different departments and across different systems to make that response so much faster. And so with that coordination, then we can address many more parts of this and minimize a lot of those different times. We still have to wait for the worker to be available. They still have to travel to the machine. They still have to fix the machine, but we're able to minimize a lot of this time on this overall timeline. And the idea here is having this integrated work cell where we have that connectivity to different systems, and the work cell isn't just a standalone system helping that individual operator, but it has much more awareness of the full context of the plant and coordination with those different systems in different areas. And then kind of a next step is, not only do we have the machine monitoring, the analytics, the integration, but now we can take those augmented reality capabilities that we talked about earlier and add those into this process as well. And so imagine that we still have the upfront part of that process where the operator's made aware right away, they know they need help, maintenance is immediately a ticket is created for maintenance and so forth. They're passed information about the type of failure that it is. And maybe instead of assigning a worker within the maintenance department to go out to the machine, maybe this is something that they're able to provide that remote assistance to the operator, and have the operator actually make that repair, but with the expert guiding them through that process. And so in a case like this, they can use their smartphone, or you could have glasses close to the equipment and so forth, where the operator is able to show maintenance what it is that they're working on with the machine. That remote expert is able to guide them through, what are the different steps that they have to take, and they can actually, instead of waiting for somebody to become available, travel out to the machine and make the, simple repair in this case. They can do that themselves and really eliminate a lot of that time where you don't even have to wait for somebody to be assigned and get out to the machine and so forth. And you can just fix the issue and get the machine running again. Another scenario in the same vein is that you still need maintenance, but you can give them those augmented reality capabilities as well, where maybe the maintenance person needs engineering support, but instead of having to leave, go find an engineer, and then eventually come back, they can utilize those same remote expert or remote assistance capabilities to get the engineer on the phone, show them what's going on with the machine, describe the details, pass that information along that came from the initial diagnosis from the expert system and so forth, and have the engineer now provide that remote assistance, or even going out to the vendor and so forth and getting remote assistance to get it fixed on the first try. And so these capabilities are tremendously powerful to not only help the operator do that initial response potentially, but also for the maintenance person to get that fixed right on the first try. And so you have this capability of the digital and augmented work instructions and so forth, with either the hands-free so that you have the glasses doing that, or again, just kind of using the phone and having the phone camera on the machine, as well as having the instructions on the phone and so forth. And so there's so many different capabilities with this, and can help tremendously in terms of reducing that amount of response time and repair time. So actually that went a lot faster than I was thinking it would. That's actually the end of the presentation for today. So we've kind of gone through, looking at quite a bit of these different steps for the mean time to repair, and how we can address those using technology. So are there any questions in terms of this presentation, or any other questions in general? If you do come up with anything that you didn't think of right now, but you want to ask me about, you can reach out to me at tim@visualdecisions.com, or you can reach out to me at 630-957-8096. And I'll probably be following up with each of you after the presentation here to see how this might be able to help in your environments. Thank you very much.